Okay, folks, we're back for lesson two, our at-home lesson. And here it is. We have already talked about solving one-step equations. You've done a couple of activities on it, and hopefully your understanding was pretty good. It's important within mathematics to remember that if you're struggling with one topic, you need to figure that out. You need to contact a teacher, watch some Khan Academy videos, or get the extra help you need before moving on, because everything builds on top of itself. So if you have a bad foundation, then it's going to be hard to continue on. Okay, so first thing we need to remind ourselves is the difference between expressions and equations. Expressions don't have equal signs, equations do have equal signs. When we're solving equations, remember that that means there is an equal sign, and we draw that line right down the middle to remind us we have two sides. Okay. Cool. Now, with expressions, when we're evaluating expressions, that was our first week was evaluating expressions. You plug in a number and simplify as much as possible to find one value, right? With expressions, we use PEMDAS when we're evaluating expressions. Parentheses, exponents, multiplication, division. Remember, those two are together, and then we have adding, subtracting, and those two are also together. Okay. Now, when we're solving equations, we use SADMIP, right? Which is the opposite, the exact opposite. Instead of starting with parentheses, you end with parentheses. Okay. So please keep in mind the opposite of PEMDAS, the addition, subtraction, then multiplication, division, and then exponents, and then parentheses. Okay. Great. Now we have an example of our evaluating expressions that we did last week where we plugged in some values and we did the exponents first here and then we added and came up with a value, or over here where we multiplied first and then added, following our order of operations. But when we're solving equations, here's an example of a two-step equation. We'll look into more of these in just a moment. We're going to do the opposite. We're going to do addition subtraction first. So we're going to get rid of this addition right here. We're going to get rid of that first. That's our first focus, our first thing that we pay attention to. And then after we've gotten rid of the addition subtraction, the AS here, we're going to do the multiplication division. And that's our DM right here, and get that 9 to the other side because that's being multiplied. That's how we solve. The opposite of PEMDAS is SADMAP, right? Which is just PEMDAS the other way around. Okay. Now, we'll do a couple of examples together, make sure that we understand. Now, using our SAD SADMIP, right? We are going to, that M's real big. Okay, we're going to use addition subtraction first. So this 4 right here is what we need to get rid of first. We know in order to solve an equation, we have to use inverse operations. And if it's adding a 4, we have a positive 4 here, we need to move that 4 to the other side by subtracting. Because it's a positive 4, we need to subtract the 4. And before we get any further, I need to remember to draw our line. Okay, now 0 minus 4 on the number line is going to give us negative 4. And 4 minus 4 right here cancels out, leaving us with just n over 5. Now that we've handled the addition subtraction, now we can talk about the multiplication division. This line in between the fraction means division. So we're going to multiply and multiply. These 5s cancel out, right? Leaving us with just the n. And the n has been isolated now. Isolated meaning by itself. And we have 5 times negative 4. A positive times a negative gives us a negative. 4 times 5 is 20. And this is completed. It is. But it is much more appropriate to write as your final answer n first. Write the variable first and then equals negative 20. It means the same thing, but we want to make it look as professional and appropriate as possible. Okay. Now, now that we've completed that problem there, let's move on. Now we have some parentheses in here, which is going to be a bit interesting. And we're going to, again, follow the inverse operations, or sorry, No. Order of operations backwards, which is our SADMAP right here. We're going to do addition subtraction first, but because this is inside of our parentheses, we're actually going to leave this alone until the very end. Okay, parentheses always go at the end when we're solving equations. So we're going to focus on this 2 first because it's multiplication division, and we're going to divide by 2. I drew this fraction bar under everything. Again, just trying to look as professional as possible, okay? So we're going to divide both of these by 2. 2 divided by 2, of course, is 1, which cancels that out, leaving just n plus 5. And we notice that our variable has not been isolated yet. There's still a 5 there. Negative 2 divided by 2. Negative divided by a positive is a negative. 2 divided by 2 is 1. Now, our last step, we'll do our addition subtraction, or the inside of our parentheses now. Parentheses are last. We're going to minus 5 and subtract 5 over here as well. And naturally, I totally forgot to draw this line. Okay. Now, positive 5 minus 5 is just 0, leaving our n by itself. Negative 1 minus 5 on the number line. If you start at negative 1 and then go negative 5 in the negative direction, we have a total of negative 6. And that is our final solution. Now, for our last example problem we'll do together, we're going to talk about this situation right here. This is a very unique situation because we have a whole expression on top of the fraction. I'm going to put some parentheses here to kind of give us a better idea of what we should do first, okay? Now, because these parentheses are here, that reminds us to do that last. So we're going to get rid of the 6 first. To help get our x by itself, we need to get rid of the 6 because this line here means division. So we're going to multiply by 6, and the 6's cancel out, but we can't do it to just one side. We have to do it to both sides, right? So multiply 6 on both sides. This gives us negative 6 is equal to 5 plus x. Okay? And we almost have our x by itself. We just got to get rid of this 5 because it's added. We're going to subtract 5, and naturally, totally forgot to draw that line. I wonder if I'll ever remember. Okay. Again, you should do better than I do, okay? Make sure to remember that. And x is now isolated because this 5 minus 5 cancels out, and negative 6, negative 5 gives us negative 11. And again, though this is the correct answer, it's much more appropriate to write the variable first, and x minus 11, okay? Now, our last thing we're going to talk about is a couple of word problems. We did some word problems with our one-step solving. Now we're going to do some word problems with 2 steps. So we have 331 students went on a field trip. So it's a big field trip, a lot of buses, right? A lot of buses, a lot of cars. So 6 buses were filled and 7 students traveled in cars. How many students were in each bus? Now, we always need to pick a variable. I'm going to pick B, number of students in a bus, is our variable. And we know that there were 6 buses. So the number of students in a bus times 6 tells us how many students were on buses total. And then we have 7 students, another 7 students went in a car, right? And 6 times all the kids in one bus, right? So 6 buses total times however many kids sit in one bus plus the 7 that went separately is equal to 331 students total that went on this field trip. Now, to solve this, we need to draw our line. Hey, I did remember. Just takes a little while in the video, I think. And we're going to solve this now that we have our equation with the equal sign set up. I'm going to minus 7, subtract 7 over here, gives us 6b. And 331 minus 7 is going to be minus 1, gives us 330, minus another 6 gives us 324 students rode the buses. So this is just the number that rode the buses. And because this is multiplied to get b by itself, I'm going to divide both sides by 6. Gives us b is equal to 24 divided by 6 is 4. And 300 divided by 6 is 54. You can do this using long division if you prefer. Long division is not my favorite, but I assume a lot of you have spent a long time learning it. Okay. Now, moving on to our next example, the sum of 3 consecutive. A bit of vocabulary here. Consecutive. Consecutive means one after the other. So consecutive numbers would be 1, 2, 3, would be 5, 6, 7, would be 21, 22, 23, would be 492, 493, 494. Those are consecutive, one after the other. We hear this word a lot when people say consecutive years. Like, let's say the Atlanta Braves we had a really good couple of years, and they won the World Cup 3 years in a row. So let's say they won it 3 consecutive years. Could be 2015, 2016, 2017 consecutive. Okay. Now, the sum of 3 consecutive numbers, this is a very challenging problem, so be patient. The sum of 3 consecutive numbers is 72. What is the smallest of these numbers? Now, I'm going to use an x to represent the smallest of the numbers. What we're looking for is a variable. So the sum tells me I'm adding. So if I take the sum of 3 consecutive numbers, 5, 6, 7, right? 1 plus 1 more plus 1 more, right? So I'm going to add x plus 1. Why am I adding x plus 1? Well, let's say the smallest of these numbers is 5. The next one would be 6, 5 plus 1, okay? Plus the next number, which let's say is 7, 5 plus 2, okay? So, and I'm going to put some parentheses here, not because you need them, but maybe because it makes it a little clearer. So the first number, let's say it was 10, the sum of 3 consecutive numbers, so 10, 11, 12, 10, 10 plus 1 is 11, 10 plus 2 is 12, and the sum of these 3 numbers is going to be 72, okay? But now, much like our first lesson, we're going to do a little bit of combining like terms. So we have 3 x's, gives us 3x, and we have 1 plus 2 is 3, is equal to 72. Now, to get this x by itself, now that we have an equation to solve, we're going to get rid of this 3 first, put the 3 to the other side, gives us 3x equals 69, and we're going to divide both of these by 3 because they're multiplied. Gives us x, I'm going to write it over here because I ran out of space, x equals 9 divided by 3 is 3, 60 divided by 3 is 23, okay? And that is our smallest number, which means our 3 numbers were actually 23, 24, and 25, okay? And same over here, this 54 represents how many students fit on just one bus, okay? It's really helpful with these word problems. Once you find the answer, say it back to yourself. What does it mean? What did you find? What does it mean in the real world, okay? Cool. I hope this was very clear. And if you have any questions, as always, please feel free to email me. The next video or the next lesson is going to be just for blue students. The blue students are the ones who found this kind of easy, so they're looking for an extra challenge, okay? And I hope to see many of you trying those blue lessons on your own. Okay, thank you.